PM2K1. For today's topic, I and Shaina will be discussing about WAN concepts. A WAN is owned by a service provider. A user must pay a fee to use the provider's network services to connect remote sites. WAN service providers include carriers such as a telephone network, cable company, or satellite service. Service providers provide links to interconnect remote sites for the purpose of transporting data, voice, and video. The following are purposes of WANs. First, it connects LANs or local area network. WANs are used to connect remote sites to the enterprise network. It is also used to connect home users to the internet, and enterprise networks are using security and privacy solutions over the internet to connect remote sites and users. Interconnecting multiple sites across WANs can involve a variety of service provider technologies and WAN topologies. Common WAN topologies are point-to-point. Employs a point-to-point circuit between two endpoints, typically involving dedicated leased line connections like a T1 or an E-line. A point-to-point connection provides a layer 2 transport service through the service provider network. Packets sent from one side are delivered to the other side and vice versa. A point-to-point connection is transparent to the customer network as if there was a direct physical link between two endpoints. Second, if a private network connection between multiple sites is required, a point-to-point topology with multiple point-to-point circuits is one option. Each point-to-point circuit requires its own dedicated hardware interface that will require multiple routers with multiple WAN interface cards. This interface can be expensive. A less expensive option is a multi-point topology, also known as a hub-and-spoke topology. With a hub-and-spoke topology, all spoke circuits can share a single interface to the hub. One of the disadvantages of hub-and-spoke topologies is that all communication has to go through the hub. With a full mesh topology, using virtual circuits, any site can communicate directly with any other site. The disadvantage here is the large number of virtual circuits that need to be configured and maintained. Fourth one, a dual home topology provides redundancy. As shown in the figure, the spoke routers are dual-homed and redundantly attached to two hub routers across a WAN cloud. The disadvantage to dual-home topologies is that they are more expensive to implement than a single-home topology. The reason is that they require additional networking hardware like additional routers and switches. Dual-home topologies are also more difficult to implement because they require additional and more complex configurations. However, the advantage of dual-home topologies is that they offer enhanced network redundancy, load balancing, distributed computing or processing, and the ability to implement backup service provider connections. Every business is unique, so how an organization grows depends on many factors. These factors include the types of products or service the business sells, the management philosophy of the owners, and the economic climate of the country in which the business operates. The example used in this chapter is of a fictitious company called Span Engineering. This topic will illustrate how Span's network requirements change as the company grows from a small local business into a global enterprise. Span Engineering, an environmental consulting firm, has developed a special process for converting household waste into electricity and is developing a small pilot project for a municipal government in its local area. The company, which has been in business for 4 years, is a small office consisting of 15 employees, 6 engineers, 4 computer-aided drawing designers, a receptionist, 2 senior partners, and 2 office assistants. 5 years later, Span Engineering has grown rapidly. The company was contracted to design and implement a full-size waste conversion facility soon after the successful implementation of its first pilot plant. Since then, Span has won other projects in neighboring municipalities and in other parts of the country. To handle the additional workload, the business has hired more staff and leased more office space. It is now a small to medium-sized business with several hundred employees. To meet its growing needs, the company has moved into several floors of a larger office building. As the business has expanded, the network has also grown. Instead of a single small LAN, the network now consists of several sub-networks, each devoted to a different department. For example, all the engineering staff is on one LAN while the marketing staff is on another LAN. These multiple LANs are joined to create a company-wide network or campus, which spans several floors of the building. Another 6 years later, Span Engineering has been so successful with its patented process that demand for its services has skyrocketed. New projects are underway in multiple cities. To manage those projects, the company has opened small branch offices closer to the project sites. This situation presents new challenges to the IT team. To manage the delivery of information and services throughout the company, Span Engineering now has a data center, which houses the various databases and servers of the company. To ensure that all parts of the business are able to access the same services and applications regardless of where the offices are located, the company must now implement a WAN. Span Engineering has now been in business for 20 years and has grown to thousands of employees distributed in offices worldwide. The cost of the enterprise network and its related services is a significant expense. The company is looking to provide its employees with the best network services at the lowest cost. Optimized network services would allow each employee to work at a high rate of efficiency. Let's move on to the WAN operations. So WAN operations focus primarily on two different layers. Physical layer or OSI layer 1 are protocols describe how to provide electrical, mechanical, operational, and functional connections. The second layer is the data layer or OSI layer 2. Define how data is encapsulated for transmission toward a remote location and the mechanisms for transferring the resulting frames. At this moment, let's define the following WAN terms. The CPE consists of the devices and inside wiring located on the enterprise edge connecting to a carrier link. The subscriber, or that is a customer, either owns the CPE or leases the CPE from the service provider. A subscriber in this context is a company that arranges for WAN services from a service provider. Second, this is an EIA term, also called Data Circuit Terminating Equipment by the ITU. The DCE consists of devices that put data on the local loop. The DCE primarily provides an interface to connect subscribers to a communication link on the WAN cloud. Third, data terminal equipment. These customer devices pass the data from a customer network or host computer for transmission over the WAN. The DTE connects to the local loop through the DCE. Demarcation point. This point is established in a building or complex to separate customer equipment from service provider equipment. Physically, the demarcation point is a cabling junction box located in the customer premises that connects the CPE wiring to the local loop. It is usually placed so that a technician can access it easily. The demarcation point is the place where the responsibility for the connection changes from the user to the service provider. When problems arise, it is necessary to determine whether the user or the service provider is responsible for troubleshooting or repair. Next, local loop. This loop is the actual copper or fiber cable that connects the CPE to the CO of the service provider. The local loop is also sometimes called the last mile. Central office. The CO is the local service provider facility or building that connects the CPE to the provider network. Last one is tool network. This network consists of the long-haul or digital fiber optic communications lines, switches, routers, and other equipment inside the WAN provider network. So, here it is, the different WAN operations terms illustration. Now, let's proceed to the common WAN devices. Dial-up modem. Voice band modems are considered to be a legacy WAN technology. A voice band modem modulates, or that is converts, the digital signals produced by computer into voice frequencies. These frequencies are then transmitted over the analog lines of the public telephone network. On the other side of the connection, another modem then modulates the sounds back into a digital signal for input to a computer or network connection. Next, access server. This server controls and coordinates dial-up modem, dial-in and dial-out user communications. Considered to be a legacy technology, an access server may have a mixture of analog and digital interfaces and support hundreds of simultaneous users. The broadband modem. This type of digital modem is used with high-speed DSL or cable internet service. Both operate in a similar manner to the voice band modem but use higher broadband frequencies to achieve higher transmission speeds. CSU or DSU. Digital list lines require a CSU and a DSU. A CSU or DSU can be a separate device like a modem, or it can be an interface on a router. The CSU provides termination for the digital signal and ensures connection integrity through error correction and line monitoring, while the DSU converts the line frames into frames that the LAN can interpret and vice versa. WAN switch. This multi-port internetworking device is used in several service provider networks. These devices typically switch traffic such as frame relay or ATM and operate at layer 2. Router. This device provides internetworking and WAN access interface ports that are used to connect to the service provider network. These interfaces may be serial connections, Ethernet, or other WAN interfaces. With some types of WAN interfaces, an external device such as a DSU or CSU or modem, analog cable or DSL is required to connect the router to the local service provider. The core router or multi-layer switch. This router or multi-layer switch resides within the middle or backbone of the WAN rather than at its periphery. To fulfill this role, a router or multi-layer switch must be able to support multiple telecommunications interfaces of the highest speed used in the WAN core. It must also be able to forward IP packets at full speed on all of those interfaces. The router or multi-layer switch must also support the routing protocols being used in the core. So here is the illustration of the WAN devices. WAN technologies are either circuit switch or packet switch. The type of device used depends on the WAN technology implemented. So a circuit switch network is one that establishes a dedicated circuit or channel between nodes and terminals before the users may communicate. Specifically, circuit switching dynamically establishes a dedicated virtual connection for voice or data between a sender and a receiver. Before communication can start, it is necessary to establish the connection through the network of the service provider. So in contrast to circuit switching, a packet switch network or PSN splits traffic data into packets that are routed over a shared network. Packet switching networks do not require a circuit to be established, and they allow many pairs of nodes to communicate over the same channel. So the switches in a PSN determine the links that packets must be sent over based on the addressing information in each packet. So, that's end my part. Here is Shaina Dian Toledo and she will continue the discussion.
Good day, I am Shaina Toledo and for my part, my topic is about selecting a WAN technologies. ISPs can connect the local loop to the enterprise edge using a variety of WAN access connection options. These technology, speed, and cost of these WAN access options vary. Each has its own set of benefits and drawbacks. Network design relies heavily on familiarity with these technologies. As shown in the figure, an enterprise can get WAN access over a public WAN infrastructure and private WAN infrastructure. Let's go first with the private WAN infrastructure. Private WAN infrastructure service providers may offer dedicated point-to-point leased lines, circuit switch links such as PSTN or ISDN, and packet switch links such as Ethernet, WAN, ATM, or frame relay. These are commonly used at home, a telephone for an instance. Whereas public WAN infrastructure, service provider may offer broadband internet access using digital subscriber line or DSL, cable, and satellite access. Broadband connection options are typically used to connect small offices and telecommuting employees to a corporate site over the internet. Data traveling between corporate sites over the public WAN infrastructure should be protected using VPNs, commonly used in companies, businesses, etc. Leased lines. When permanent dedicated connections are required, a point-to-point link is used to provide a pre-established WAN communications path from the customer premises to the provider network. Point-to-point lines are usually leased from a service provider and are called leased lines. Advantages of these are simplicity, quality, and availability, while disadvantages are cost, limited flexibility. ISDN or Integrated Services Digital Network is a circuit switching technology that allows digital signals to be carried over a PSTN's local loop, resulting in higher capacity switch connections. ISDN transforms the PSTN's internal connections from analog to time division multiplexed or TDM digital signals. The two basic types of ISDN interfaces are as follows. One is the Basic Rate Interface or BRI. ISDN BRI is intended for the home and small enterprise and provides two 64 KB per second bearer channels for carrying voice and data and a 16 KB per second delta channel for signaling, call, setup, and other purposes. The BRI channel is often underused because it has only two channels to control. Primary Rate Interface or PRI, ISDN is also available for larger installations. In North America, PRI delivers 23 channels with 64 kb per second and 1 channel with 64 kb per second for a total bit rate of up to 1.544 MB per second. This includes some additional overhead for synchronization. Frame relay is a simple layer of two non-broadcast multi-access or NBMA WAN technology used to interconnect enterprise LANs. A single router interface can be used to connect to multiple sites using permanent virtual circuits or PVCs. PVCs are used to carry both voice and data traffic between a source and destination and support data rates up to 4 MB per second, with some providers offering even higher rates. Asynchronous transfer mode or ATM technology is capable of transferring voice, video, and data through private and public networks. It is built on a cell-based architecture rather than on a frame-based architecture. ATM cells are always a fixed length of 53 bytes. ATM was designed to be extremely scalable and to support link speeds of T1 per E1 to OC12 and faster. As with our shared technologies, ATM allows multiple VCs on a single leased line connection to the network edge. Note that ATM networks are now considered to be a legacy technology. Ethernet was originally developed to be a LAN access technology. Originally, Ethernet was not suitable as a WAN access technology because at that time, the maximum cable length was 1 kilometer. An Ethernet WAN offers several benefits: reduced expenses and administration, easy integration with existing networks, enhanced business productivity. MPLS has several defining characteristics. It is multi-protocol, meaning it has the ability to carry any payload, including IPv4, IPv6, Ethernet, ATM, DSL, and frame relay traffic. Very Small Aperture Terminal or VSAT is a solution that creates a private WAN using satellite communications. A VSAT is a small satellite dish similar to those used for home internet and TV. Specifically, a router connects to a satellite dish that is connected to a service provider satellite. DSL technology is an always-on connection technology that uses existing twisted pair telephone lines to transport high bandwidth data and provides IP services to subscribers. A DSL modem converts an Ethernet signal from the user device to a DSL signal and which is transmitted to the central office. Cable modems or CMs provide an always-on connection and simple installation. A subscriber connects a computer or LAN router to the cable modem, which translates the digital signals into the broadband frequencies used for transmitting on a cable television network. Increasingly, cellular service is another wireless WAN technology being used to connect users in remote locations where no other WAN access to technology is available. As shown in the figure, many users with smartphones and tablets can use cellular data to email, surf the web, download apps, and watch videos. These are two common cellular industry terms. 3G or 4G wireless, abbreviation for third generation and fourth generation cellular access. These technologies support wireless internet access. Long-term evolution or LTE refers to a newer and faster technology and is considered to be part of fourth generation technology. Now, a VPN is an encrypted connection between private networks over a public network, such as the internet. Instead of using dedicated layer 2 connection, such as a leased line, a VPN uses virtual connections called VPN tunnels, which are routed through the internet for the private network of the company to the remote site of employees' host. Using VPN offers several benefits: cost savings, security, scalability, compatibility. Now, there are two types of VPNs. First is site-to-site VPNs, that connects entire network to each other. For example, they can connect a branch office network to a company headquarters network. Each site is equipped with a VPN gateway, such as a router, firewall, VPN concentrator, or security appliance. Second is the remote access VPNs, or remote access VPNs enable individual hosts such as telecommuters, mobile users, and extranet consumers to access a company network securely over the internet. Each host typically has VPN client software loaded or uses a web-based client as shown in the figure. And that is our report for today about WAN concepts. Thank you so much for listening.